Doing problem 1 from section 4.5. So first one, we've got y is equal to the natural log of 8x. So you have a choice on this one. You can either use the properties of logarithms, which I actually suggest that we take advantage of every time we can. Whenever you've got the logarithm of a product, remember that you can write it as the sum of two other logarithms. So like that. And then we can take the derivative of that, a little bit easier. Although in this case it really wouldn't have made that much difference, but again, just to practice the rules of logarithms here. That's a constant, so its derivative is 0. The derivative of that is 1 over x. Okay, for b, we'll just go as far as we can on this, and then we'll do another video once we run out of room here. We've got y is equal to natural log of absolute value 4x squared minus 9x. And again, remember that it really doesn't matter that we have these absolute value bars here. The derivative is treated in the same way. So we're looking for dy dx here. Remember that we use the formula. This thing that's here is f of x. So the formula for the derivative of the natural log of a function is the derivative of this thing, which we get as 8x minus 9 divided by that thing. So 4x squared minus 9x. Okay. Or c, we get product. So y is equal to negative 5x ln 3x plus 2. Okay, so for the derivative here, again, this is a product, so we want to use the product rule on that. So we'll take the derivative of the first one, which is minus 5, multiply it by the second. And then to that we add the first function times the derivative of the second. So negative 5x. The derivative of the second, we need the logarithm rules for differentiating a logarithm. That's the inner function here, 3x. Its derivative is 3. Divide that by the function itself. So we get that. Let's go ahead and simplify this a little bit. We're going to get minus 5 natural log of 3x plus 2. And then here we can put the minus in front. We can move that stuff into the numerator. So we get 15x over 3x plus 2. Okay. I think we can probably squeeze the next one up here. For part D, I'm going to get a better marker that's not squeaking so much. Let's see. Yeah, I think we can fit D up here. That's even same squeakiness, but we'll try to get through it. So here we've got ln x over 4x plus 7. Okay. This one is now a quotient, so we'll use the quotient rule on that. So we'll get dy dx is equal to, remember it's low d high, so the low function, 4x plus 7. D high, that's the derivative of the top function, that's 1 over x, minus the high function times the derivative of the low one, high d low. That's just 4. And then we divide all that by the bottom function squared. Okay, we can simplify this a little bit. In this particular case, I would probably just go ahead, since we have a sort of complex fraction here, we've got a fraction within another fraction. The best way to sort of deal with that is just to multiply everything by the denominator of that fraction there. So what I mean is, we'll take the whole numerator, multiply it by x, and then we have to multiply the denominator by x as well. Now if I distribute that x over here to this first term here, it's going to cancel with the x in the denominator, so all I'm going to have left is this 4x plus 7. And then when I distribute it to the second term, I just have to multiply that whole thing by x, so I'm going to get minus 4x ln x. And then the denominator, just leave that as it is, x times 4x plus 7 squared. Okay, now again, if you're actually entering this sort of answer into MyMathLab, which you definitely will be doing, I believe it would just take the answer as we had it written at first without trying to simplify it. But for future reference, we don't usually like to see these complex fractions in here, so this is really the best way to deal with that. Whatever is in the denominator of that fraction within the fraction, just multiply by it, and then that will cancel it. But you have to multiply everything by it to make sure that you're not changing the function. Okay, we'll finish the rest of these on the next video.